Hello, Bacho. So today we are doing physics part test 9 and let's solve together. Correct? So we are having question number 1. Heat is supplied to a certain homogeneous sample of matter at a uniform rate. Its temperature is plotted against time as shown in the figure. So we are able to see temperature time graph is there. They are asking which of the following conclusions can be drawn. Its specific heat capacity is greater in greater in solid state than in the liquid state. So we are able to see that here it would have been solid and here it is still solid, but here it is going to convert to liquid, here it is liquid, and here it is going to become vapor. So we are able to see that this amount of heat is given from here to here, and this is the amount of heat that is given to from here to here. We can see there is a slope difference. So the slope of the part where the liquid is changing its temperature is little bit more than the slope where the part solid is changing its temperature. That means rate of change of temperature is little bit more for the liquid. That means with the same amount of heat you can change the temperature of the liquid quickly. If you can change the temperature of the liquid quickly, that means the specific heat capacity will be little bit less. So that means in the solid, specific heat capacity is little bit more. One more option we can see here, latent heat of vaporization is smaller. No sir, it is greater. We can see that it is taking a lot of time, and here it is taking less time. Next question, we are able to see that the sun with a surface temperature 6000 Kelvin has maximum emission at 5000 angstrom. The temperature of the star whose maximum emission is at 4500 angstrom will be. So we can see that lambda is inversely proportional to temperature, or we can write lambda 1 T1 equals to lambda T 2 T2, correct? So lambda 1 by lambda 2 is basically T2 by T1. Now what is lambda 1 here? Lambda 1 is basically 5000 angstrom, and what is lambda 2? It is 4500. And what is T2? That we have to figure out, correct? And what is T1? T1 is 6000 Kelvin. So this is what we need to do. So T2 is going to become 5000 into 6000 divided by 4500 angstrom. Remember, this is everything is in angstrom. You can just remove it also, 10 to the power minus 10. So this will be, this is 6000, right? So this is going to become 4 this is going to become 3 correct? 15 4 15 3 So here we are having 2000 by 3. 2000 by 3 is basically 6600.7. Now next question we are having is, a mass of material exists in its solid form at its melting temperature 10 degrees Celsius. The following processes then occur to the material. The amount of energy, alright, we are able to see that there is some energy they are adding to it. What is the energy they are adding to it? Q, and 3 by 4th of the material is melting. So 3 by 4 ml is the energy. We are giving some energy Q, and 3 by 4 ml is being used. Next, they are saying an identical additional amount of energy Q only is given, and the material is changing its temperature to 50, basically from 10 degrees Celsius to 50 degrees Celsius it is changing. So change is happening of 40 degrees Celsius. And how much it will be used for change the state? It would be ml by 4 plus it would be mc delta T. And what is delta T here? 40. So we can see that equation 1 and equation 2 both are equal. So 3 by 4 ml equals to 1 by 4 ml plus mc 40. Yes or no? So it is going to become 3 minus 1, which is basically 2 by 4 ml equals to mc 40. So here we are having cancel. This is 1 by 2. So L by C is going to become here 80, correct? So this is our 80 degrees Celsius. Next one we are having here is a heat source has 10 to the power 3 Kelvin. So basically we can see that a rod is there and some sort of reservoir is there. This is basically 1000 Kelvin, and this is basically 10 to the power 2, basically 100 Kelvin. Now they are saying it is 1 meter thick. Basically this is 1 meter, and given that thermal conductivity, so K is basically 0.1 watt per Kelvin meter. Yes or no? The energy flux through it in the steady state is basically, what is heat current? Heat current is a delta T by R. temperature difference by thermal resistance, correct? Now if I want to calculate heat, they are asking me energy flux. Energy flux is basically R equals to L by Ka, so it is going to become L by Ka, correct? So I want to calculate energy per unit area, है ना? So it would be basically heat, or I can say heat current per unit area will be my uh, energy flux. So it would be delta T into K by L. What is delta T for me? It would be 900 0.1 by 1. So basically it is 90 watt per meter square. So our option is A. Very good, sir. समझ में आ गया. What is the next question? We are able to see that question number 5. Question number 5 क्या बोलता है सर? Question number 5 बोल रहा है सर, a traveling harmonic wave is represented by the equation this, x and y is in meter and t is in second. बताओ सर speed क्या है? सर speed तो मेरे को पता है सर, omega by k. And what is omega बच्चे? We can see that it is traveling in the negative direction, so it is going to become basically 50 by 2. So 50 by 2 is going to become basically 25 meter per second. So this is going to become our A option, negative x-axis, correct? So now question number 6, we are able to see two metallic blocks M1 and M2 of same area of cross section are connected to each other. So we are able to see that this is going to become 100 degrees Celsius and this is somewhere 80 and this is 0 degrees Celsius, correct? They are saying now calculate the thermal conductivity. We know that heat current will be same, H1 equals to H2. So it will be 100 minus 80 by L by Ka. So what is L here? 16. Area is same and this K we do not know. Let's call it K1, correct? So this is going to become here 80 minus 0 multiplied by L by K. What is L here? 8 into K. We are calling it, obviously M2 is given K. And this area is still A, so this is 8 2s are 16. This is going to become 20 by 2 10. It is going to become K1 equals to 8K, correct? So this becomes our B option, correct? Then we are having at what temperature a gold ring of diameter 6.230 meter heated. So we are able to see that it is fitted into a wooden bangle of diameter 6.241 centimeter, and both the diameters have been measured at the room temperature 21 degrees Celsius, and alpha is given to us as 1.4 into 10 to the power minus 5. So we want to calculate now, we want to calculate what is our change, at what temperature it will be fitted, correct? So now we know a formula. What is the formula we are having, sir? Change in diameter will be original diameter d alpha delta t, correct, sir? Very good, sir. Now what we have to do, sir, delta d, we know basically delta d because this is our change in diameter. So 6.241 minus 6.230 equals to 6.230. Alpha is 1.4 into 10 to the power minus 5 delta t, correct? So here we are able to see that this will be 6.241 minus 6.230, which is our 0.011 divided by 6.230 into 1.4 into 10 to the power 5, correct? So we need to divide it with 6.230, which is going to become basically this 0.000. So basically this is going to come somewhere around, after division, coming and divided by 1.4 also, right? So this is coming 0.0, so it is coming around 126 degrees Celsius. So delta T is 126 degrees Celsius. So what would be the temperature at which we need to heat it? It will be 126 plus 27 degrees Celsius, because this was the initial. So we are going to have somewhere around 153. The closest option is our 152.7. Now next one, what we are able to see there, 2 moles of an ideal monatomic gas occupy volume V at 27. So what is the temperature here? 27 degrees Celsius. And what is the volume? V1, V. What is the V2? It is 2V, sir. And what is the temperature? We are supposed to find. So we know that, sir, it's a adiabatic process. So we can say that 2 moles here. also 2 moles are given. So adiabatic process is given as T1 V1 to the power gamma minus 1 as T2 V to the power gamma minus 1. So T1 by T2 equals to V2 by V1 gamma minus 1. What is T1 by T2 here? So T1 is 300 and we want to find T2, and this is going to become V2, which is 2V by V, which is 2 to the power 5 by 3 minus 1, which will be 2 by 3 T2, correct? So this is going to become for us 300 divided by 2 to the power 2 by 3, which is basically multiplied by 2 to the power minus 2 by 3, correct? Equals to 2 T2, and this is 300 into 0.63, which is given to us. So basically 63 into 3, somewhere around 189. Okay, sir, I got 189 Kelvin, but the problem is that there are two options which are having 189 Kelvin. So we have to calculate the change in internal energy also. Now change in internal energy, simple formula is there. We know that NF by 2 R delta T. But we are smart people. Wow, sir, we are able to see that it is adiabatically expanding. So basically temperature is going to decrease. I can see that. So internal energy is also going to decrease. So I can see that if 189 is my answer, other answer has to be in minus. So basically C becomes my answer. You can calculate from here. Now what is the next? Sir, a hypothetical gas expands adiabatically such that its volume changes from 8 liter to 27 liter. Okay, sir, volume is 8 liter and V2 is 27 liters. Okay, the ratio of initial pressure of the gas to the final pressure of the gas. Okay, P1 by P2 is 16 it is to 81. Okay, sir. So Cp by Cv they are asking, but say Cp by Cv is gamma basically. But we can see a problem here that pressure is also increasing and the volume is also increasing, and we know that gas's expansion is happening, volume will increase but the pressure is going to decrease. So I think this should be 81 by 16 in order to get the answer, correct? So we are writing here 81 by 16, and this will be our V2 by V1. So 27 by 8 and to the power gamma, which is going to become gamma here. So we can write 3 by 2 to the power 4. This will be 3 by 2 to the power gamma. So this will be 3. So we can write gamma equals to 4 by 3, correct? So this is our answer. Next one. Sir, we are able to see that heat energy of a 184 kilojoule. Oh, sir, 184 kilojoule heat is given to the ice. Ice, how much ice is there, sir? Ice is 600 gram. And what is the temperature of the ice? Temperature of the ice is minus 12 degrees Celsius. The specific heat capacity of ice is also given. It is 22,223, correct? And latent heat is also given 336. So basically, while looking at the options, I am able to understand, sir, they are giving heat and some amount of ice is being melted and some amount of water is still there basically, or maybe all of the ice is melted, maybe everything is at different temperature. So we just need to figure out. Sir, we'll do one thing, we'll just figure out how much heat is required to change the ice at minus 12 degrees Celsius to convert it to, not convert, to change it to 0 degree Celsius ice. So what is the mass here? Sir, mass is 600 gram basically, divided by 1000. Sir, what is the specific heat capacity? Sir, 22,223 multiplied by, what is the change in temperature? Sir, 12. So I can see, sir, here 22,223 multiplied by 12 and multiplied by 0.6 becomes somewhere close to 1,60,000, correct? So this is approximate answer. 1,60,000 you can take. This much amount of heat energy has been used to just make this ice at 0 degrees Celsius. Now this ice at 0 degrees Celsius also has to go from ice 0 degrees Celsius to 0 degrees Celsius water. So now tell me how much amount of energy is left out. Almost 24,000 is left. So basically we are having 24,000. Basically we are having 24. I'll just write it as 1,60,000. Okay, we are just taking an approximation. So 1,60,000 we have used, and how much is remaining now? Remaining Q2 is basically 24,000, right? So 24,000, so we are using Q equals to ml, and now 24,000, all of it we have given. And what is the mass? Sir, we want to calculate. And what is L? It is 336 into 10 to the power 3, correct? So we are able to see that this will be cancelled. So 24 divided by 336, we are going to get somewhere around 0.0714 kilogram, correct? So we are able to see that this much amount of ice has been melted. Now how much water is left? Sir, water will be basically total ice minus how much water that has been converted. So if we are going to subtract it from zero point 0.6, so we are going to get approximately water will be, sir, okay, sorry, my bad, how much ice will be left, है ना? So this is basically, this is what we have become water, and what is the ice is left? It is 0.528. All right, sir. So if we look at the ratio, now we are having ice is 0.528, which is almost not melted, and water, which is like melted ice, it is around 0.071, correct? So now look at the ratio ones. They are saying final temperature of the system will be at 0 degrees Celsius. Has to be correct, sir, because ice is also there, water is also there. And next one is final temperature. Okay, ratio they want us to calculate. So we will divide. They are asking us ice and water, and uh, ice and water in the ratio 5 is to 1, ice and water in the ratio 1 is to 5. So we'll just check once. We are going to divide it with 0.071, and we are going to get somewhere around 7.5. So basically we are able to see that ice is more. Ice to water, we are able to see that ice is 7.5 is to 1. 7.5 is to 1 is basically answer 5 is to 1 coming. So we can see that this has to be changed. It would be around 7 is to 5 is to 1, 7.5 is to 1, and this would be 1 is to 7.5, or you can say that. So answer has to be A, and 7.5 is to 1, which will be basically C, correct? So this is our correct answer. Little bit, I think key is incorrect. Options are incorrect, sorry. So what is the question number 11? Question number 11, we are able to see that we are having a gas which is basically oxygen, correct? So what is the temperature of the gas, sir? Temperature of the gas is 300 Kelvin. What is the RMS of speed of the gas? So they are saying that RMS speed of the gas is basically root of alpha plus 5 by alpha times to that of the average speed, correct? So we are able to see that root 3 RT by M equals to root alpha plus 5 by alpha multiplied by average. What is the average speed? It is root 8 RT by pi M. सर आई एम एबल टू सी दैट सर आर टी बाई एम सर स्क्वायर कर देंगे दोनों साइड पे. इट इज़ गोइंग टू बिकम एल्फा प्लस 5 बाई एल्फा, and it is going to become 8 by pi, correct? So it is going to become 3 alpha pi, and this is going to become 8 alpha plus 8 5s are 40, correct? So it is going to become here 22 by 7, so 3 alpha 22 by 7, and this is minus 8 alpha equals to 40. So we are having a 66 alpha minus 56 alpha. So 66 alpha minus 56 alpha by 7 equals to 40. So this is going to become 4 6 10. 10 alpha equals to, this is 10 alpha equals to this 10 alpha 4s are 4 alpha is going to come basically 28, correct? So alpha is 28. Do we have? Yes, sir. Alpha is 28. Correct. So now what is the next question we have? We are able to see that next question is RMS speed of a chlorine molecule is 490 meter per second at 27 degrees Celsius. And argon molecule at the same temperature will be. So we know that, sir, VRMS speed is basically root 3 RT by M. And they are saying at the same temperature, that means VRMS 1 by VRMS 2 will be root M2 by M1. बच्चों yes or no? सर root M2 तो आपने बताया था, कितना है बच्चे? So they are saying M2 is basically, so they are saying speed of chlorine is 490, and this we have to figure out, right? So this is going to become M2 by M1. What is M2 here? M2 chlorine is there. So argon, what is the mass of argon, bacho? It is 39.9, correct? So 39.9 divided by, it is going to become 70.9, correct? 39.9 and this is 70.9. So we are able to see here, uh, just let me check once. So VRMS is root 3 RT by M. This is 1, this is 1. So this is going to become 1 by M1 by, so it would be M2 by M1, correct? I think molecular mass of chlorine is this, argon is this, correct? So, so 300 degrees Celsius, right? So it is going to become 39.9 divided by 70.9, correct? So which is basically 0.56. So 0.56, and here we are having, what is the speed, bacho? It is 490 by, it is V2. V2 would be the speed of the argon, correct? So now we are having root of 0.56. So root of 0.56 will be somewhere around root 0.75. So 490 divided by VRMS will be 490 divided by 0.75 approximately, है ना? So it is going to become 490 divided by 0.75. It will be approximately 653 point something. So this is going to be 651 is my closest answer. So that will be correct. Now what do we have here? Sir, 1 kilogram of water at 100 degrees Celsius is converted into steam by boiling at atmospheric pressure. The volume of water changes from 1.1 into 10 to the power minus 3 to liquid 1.671 meter cube as steam. The change in internal energy, है ना? So बच्चे internal energy का formula क्या होता है? सर वो सब तो ठीक है, but how would I know? They are asking me atmospheric pressure. How would I know what is the change in internal energy? Sir, Q equals to delta U plus W, right? Yes or no? And we know that this process that is happening, it is happening basically, sir, under constant pressure, correct? So constant pressure, we know that what is the work done, sir? It is P delta V, correct, bache? So what is pressure here, sir? 10 to the power 5, sir. What is delta V here, sir? It is 1.67 meter cube, 1.671 meter cube minus 1 into 10 to the power minus 3, correct, bache? Yes or no? So it will be, sir, 10 to the power 5. It would be 1, it would be 1 by 1000. So it would be 1671 minus 1 by 1000. So it will be around 1670 into 10 to the power 3. Acha, sir. So 1670, sorry, my bad, 1670 by 100. So it will be 10 to the power 3, correct? So now this will be approximately 167 into 10 to the power, you can say that this will be kilojoule, right? Let's check one more time. So what we are having here, 1.671. So 1 by 1000, it will be, sorry, this is 1000, sorry bacho, this would be 1000. So it will be, my bad, so it will be 1000. So it is going to become 10 to the power 5. This will be 1670 by 1000. So which is going to become basically 167 kilojoule approximately, correct? Now we know that it is 167 kilojoule, and they are asking us what is the change in the internal energy, delta U. So we know work done. Do we know Q now? Sir, Q, how we are going to figure out? Sir, it is converted into steam. So Q is going to become, bache, Q equals to ml, है ना? How much water is there, sir? It is 1 kilogram. 1 kilogram of water at 100 degrees Celsius is converted into steam. That means what is the latent heat of vaporization? It is 2257. So this much amount of kilojoule is basically heat that we have given to it, correct? So the total, it is going to become 2257 minus 167, correct, kilojoule mein. So answer is going to come somewhere around 2090 kilojoule. Okay, sir. Sir, एक बात बताओ, I am able to get 2090, but there are two options. One is plus, sir, one is minus. Sir, the change in internal energy is positive or negative, bache? It is positive. Why? Because we are able to, we are changing temperature here. We are changing 100 degrees Celsius to 100 degrees Celsius only, but there is a positive work done because we are able to see this work done is there, and if we are going to do Q minus W, we are going to get delta U positive. So this one will be our positive answer. All right, what is the next one? The root mean square speed of molecules of nitrogen at 27 degrees Celsius is approximately. All right, Bacho. So basically they are asking molecules of nitrogen. Sir, I know VRMS formula, it is root 3 RT by M. No, bache, we are going to apply here root 3 KT by M. Sir, why root 3 KT by M? Because it is a molecule. So we are having 3 into Boltzmann constant is 1.10 to the power minus 23 into what is the temperature? We need to keep in Kelvin. This is 300 and mass is 4.6 into 10 to the power minus 26 kilogram. We are going to solve it and we are going to get something around 523 meter per second. This is coming after solving. You can solve it. So there is absolutely correct way. Okay. So what is the question number 15? Now what is question number 15 for us? Question number 15 is saying consider two containers A and B containing monatomic gases at the same pressure, volume and temperature T. The gas A in A is compressed to isothermally to 1 by 8 of its original volume. अच्छा sir, isothermal process के लिए we know that P1 V1 equals to P2 V2. Correct? So P1 by P2 equals to this will be V2 by V1, and here I want they are saying gas is compressed isothermally to 1 by 8 of its volume. That means V2 is 1 by 8 of V, so which is going to become basically 1 by 8, and this will be P1 by P2. So we can say that 8 P1 equals to P2. Correct? Now they are saying while the other gas B is compressed adiabatically to 1 by 8th of its original volume. Acha sir. So P1 V1 to the power gamma equals to P2 V to the power gamma, sir. And what kind of gas it is? Sir, it is a monatomic gas. Alright, bacho. So monatomic gas at P1 by P2, sir, V2 by V1, sir. And again the same thing. It is 1 by 8th this time. But what is the gamma here? Gamma is here. Acha, they are asking us gamma, correct? So we are able to see that, the ratio of final pressure of the gas B to that in the gas A, and we know that what is our gamma? Gamma is going to become our 5 by 3, correct? So what we have here is a P1 by P2, so this will be 2 1 by 2 to the power 5, it would be 32. So we can say that P1 would be, it would be 1 by 32, correct? So it would be 32 times P1 equals to P2, correct? So we are able to see that now what is the ratio? Ratio is going to become 32 times P1 by 8 P1, so it will be basically 4, correct? So this is our answer, ratio of final pressure of gas B to the gas A, gas B to the gas A, correct? All right. Now what is the next one we are having? If 3 moles of monatomic gas gamma equals to 5 by 3 is mixed with 2 moles of diatomic gas gamma equals to 7 by 5, the value of adiabatic exponent for the gamma for the mixture is. बच्चों अगर हमको गामा मिक्सचर का निकालना है तो हमको सी पी किसकी लिखनी पड़ेगी बच्चों? मिक्सचर की, ये सुनो. एंड हमको सी वी किसकी लिखनी पड़ेगी बच्चों? मिक्सचर की, करेक्ट? सो वी आर गोइंग टू राइट N1 CP1 प्लस N2 CP2 डिवाइडेड बाई N1 प्लस N2 कैंसिल हो जाएगा, तो वी कैन राइट N1 CV1 प्लस N2 CV2, करेक्ट? ये सुनो. सो हियर वी आर गोइंग टू गेट नाउ N1 कितना है बच्चे यहाँ पे 3 मोल्स, N2 CP कितना होता है बच्चे फॉर 2 moles of the 3 moles of a monatomic gas. Monatomic gas के लिए you are going to write 5 by 2R plus this will be R 2 into 7 by 2R divided by कितना हो जाएगा बच्चों? 3 into 3 by 2R plus 2 into 5 by 2R, correct? So which we are going to write, this will be 15 by 2, this will be 7, and this will be 3 3 is a 9 by 2, 4.5, this will be 5R. So which is going to become somewhere around 21 by 19, है ना? So कितना हो रहा है बच्चे यहाँ पे? This is going to become somewhere around 1.5 के approx. So this should be our answer. Clear है? Now what is the next question? We are able to see temperature of a gas is minus 78 degrees Celsius and the average kinetic energy of its molecule is K. Okay, bachcho. So what is the average kinetic energy of any gas, sir? It is 3 by 2 kT, sir. Translation kinetic energy, sir, for a monatomic gas, sir. Okay, sir. So monatomic gas के लिए only translation kinetic energy is there. They did not give us monatomic or diatomic. Anyway, the kinetic energy is basically 3 by 2 kT for a molecule. Sir, I can see that they are saying temperature of which is, they are asking when it is going to become double. So when it is going to become double, but when the temperature is going to become double, right? So kinetic energy 1 divided by twice of kinetic energy 1, correct? So this is going to become T1 by T2. Now what is the T1 we are having, bachcho, here? T1 we are having 273 minus, I mean like plus we are going to do, so it will be basically 195. So this is going to cancel. We are going to get 195 into 2, which is going to become approximately 390, है ना? So 390 Kelvin, if we are going to get 390 Kelvin minus 273, if we are going to do, we are going to get 117, correct? 117 will be our correct answer. Now the next one we are able to see is a real gas with a closed chamber at 27 degrees Celsius undergoes a cyclic process as shown in figure. The gas obeys PV cube equals to RT. All right. For the path A to B, the net work done in the complete cycle R is given as 8 joule per mole Kelvin. अच्छा sir. Sir, लेकिन if we are going to do, we are able to see PV cube by RT. So we need to calculate what would be the, if we have to do work done. So work done will happen in this process and this process, right? Yes or no? So if it is happening, we need to calculate P1 V1 to Q and P2 V2 Q, है ना? P1 by V2. So temperature they are taking. So basically here they have not given enough information about the temperature, bachcho. So what you do is, I think this question is I gave bonus, right? Yeah, I think this is not making sense here, so you can leave it. The next one, let's come to the next one. What we are able to see here, a mixture of 1 mole of a monatomic gas and 1 mole of a diatomic gas. They are at the room temperature and we are looking to figure out the ratio of the specific heat capacity. CV का ही रेशियो पूछ रहे हैं बच्चे CV का रेशियो तो बहुत आसान है सर. CV का रेशियो क्या होता है सर? CV इक्वल्स टू 3/2R होता है सर मोनोटॉमिक के लिए, और सर डायटोमिक के लिए सर it is going to become 5/2R, correct? So basically 3/2R into 2 by, this is going to become R, so this will be RR 2, this will be 3/5. So 3/5 shall be our answer. Now we are having this question. 1 mole of a monatomic ideal gas undergoes process J to K, L to M, M to J as shown in the diagram, PT diagram, correct? So now we are able to see that there are some things are given and we have to check. Okay, nice mix and match. So first thing, let's see that what is happening, है ना? So M to J we are able to see that it is isothermal process. J to K is a isobaric process. L to K to L again it is a isothermal process, and L to M again it's a isobaric. But J to K we are able to see that key temperature is increasing, correct? Yes or no? And isobaric process. So do we have these processes here? Change in the internal energy, Jk, heat given. Let's do one thing. Let's heat given to the gas in the whichever is easier for us to calculate. Let's start with that. So they are saying change in the internal energy of the gas in process Mj. So I am able to see that Mj is basically iso thermal process and there is no change in internal energy. So basically S has to be 2. Alright, sir, that means either my B could be correct or my C could be correct. Let's check the next one. Heat given to the gas in the process KL. Heat given to the gas in the process KL. Okay, sir, KL is, I know that Q equals to, बच्चे क्या होता है isothermal process में W होता है. That means they're asking W. Sir, W can be written as, sir, nRT. What is the temperature here? 3T, बच्चे. And what is the pressure we are changing, sir? Pressure, we are going from initial pressure P0 to 2P0, and we know that it is P0 by 2P0, so it is going to become 1/2, correct? Work done का formula सबको पता है बच्चों, nRT ln Pi by Pf. So we are going to get ln 1 by 2 कितना हो जाएगा बच्चे माइनस ln 2. So we are going to write minus m 3r t naught ln 2. कहीं है दिख रहा है हमको ये? यस सर 5 दिख रहा है हमको. So jk is basically sorry my bad, kl is r is basically 5. So r is 5, s is 2. अच्छा sir, so r is 2 here. Okay, so already we are confirmed that almost D will be our correct answer because B will be our correct answer because anywhere else it is not matching. But let's solve the other part also. They are asking change in the internal energy of the process JK. So change in the internal energy. सर इंटरनल एनर्जी पता करने के लिए मुझे क्या पता करना पड़ेगा यहाँ पे Q इक्वल्स टू डेल्टा यू प्लस डब्ल्यू. सर डू आई नो द वर्क डन, डू आई नो द डेल्टा यू? सर डेल्टा यू तो यू कैन कैलकुलेट सर, एन एफ बाई टू आर डेल्टा टी. बच्चे कितना हो गया यहाँ पे? दिस इज 1 mole, so it is going to become 1 into 3 by 2 r. And what is delta G change in temperature? So 2 T naught, so it would be basically 3 RT. So change in the internal energy of the process, no mj, we got jk, right? Change in the internal energy is going to become 3 RT. So q has to be 3. Array sir, we got our answer sir, q is 3 and this is what we have got correctly. Correct. But say likewise we can solve the work done also for the whole cycle. All right bacho, next one. What is the next question we are having here? Next question is, in the following table the number of molecules Ni moving with a definite velocity Vi are given and they're asking is what is the mean. All right, normally we have mean formula, but we can also calculate average by the old average method. What is that? N1 V1 plus N2 V2. This is basically N1, right? Capital N. So N2 V2 plus N3 V3 plus N4 V4 plus N5 V5 divided by, you know the deal, N1 plus N2 plus N3 plus N4 plus N5. Correct? Yes or no? So what we are able to see, this is basically 2, this is basically 2 4s are 8, this is 3 5s are 15, this is 8 4s are 12, this is 5 2s are 10 divided by N1 plus N2 कितना हो गया बच्चे? 4 plus 2 6, 6 plus 5 हो गया 11, 11 8 हो गया 19, 19 plus 2 हो गया 21. तो यहाँ पे हो गया बच्चे हमारे पास 8 plus 2 10, 10 10 20, 20 30 32, 32 plus 5 37, 47 by 21. सर ये हो गया, हाँ सॉरी बच्चे, इट इज़ गोइंग टू, एक सेकेंड कुछ गड़बड़ हुआ है क्या यहाँ पे? एक सेकेंड लेट्स डू दिस अगेन. यहाँ पे हमको क्या दिख रहा है बच्चे? दिस इज़ 1 into 2 2, 2 4s are 8, 3 5s are 15, 4 8s ओके यहाँ पे इधर यहाँ पे लिख दिया हमने गलती से. ये हो गया बच्चे 2 plus 8 plus 15, 2 plus 8 plus 15 and this going to become 8 4s are 32 plus this is going to become 10. Now here we are having 2 plus 4 plus 5 plus 8 plus 2. Correct. So now we are having 8 4s are 32 plus 5 2s are 10. तो बच्चे ये हो गया हमारे पास 32 plus 8, it is 40 40 50 52 52. ये हो गया 52 62 and 67 by 21 which is approximately बच्चों 3.1 3.19 3 मीटर पर सेकेंड आप लगा सकते हैं क्योंकि इंटीजर टाइप है तो वी कैन राइट 3.3 मीटर पर सेकेंड. Now what is the next question? We are able to see that S wave, which is transverse, and P wave, longitudinal, produced by earthquake, travel at different speed through the earth. If the S wave travel around 4000 meter per second, so this is the S wave ka speed, and we are able to see P waves travel with 7000 meter per second, and how far in kilometer must okay. So basically we have to figure out how quickly they are traveling, how quickly we can feel the earthquake. So basically we need to calculate the, now what would be the time for the P waves to travel. P waves में कितना लगेगा बच्चे D distance to travel करने के लिए? It would be D by 7000. और S wave में कितना लगेगा? It would be D by 4000. Correct. So now tell me, they are saying that it is going to be have a difference of 2 minutes. So basically 120 second equals to, this will be D by 4000 minus D by 7000, right? So D by 4000 minus D by 7000. So it will be 7000 minus 4000, it will be 3000 D, and it would be 4000 into 7000, which is going to become 4000 into 7000, correct? So now we are having here D, मेरे को कैलकुलेट करना है, ये हो जाएगा मुझे 3 0 गए, ये हो जाएगा 28,120, एंड डी हमारे पास आ जाएगा 123, ये हो गया 1130 zeros. So we can what, and this will be by 3. So 3 4s are 12. So this is going to become 40, and this is also 28, right? So it is going to become approximately 112, and which is going to become, so we can write it as 112 into 10 to the power 3, which would be 1120 kilometers, right? Now next one, what we are having here, two waves executing simple harmonic motion traveling in the same direction with the same amplitude and frequency are superimposed. The resultant amplitude is equal to root 3 times of the amplitude. Okay, so basically they are asking what is our net. So this is going to become root a1 square plus a2 square plus 2a1 a2 cos phi. They're asking us what is cos phi. So this is going to become बच्चे a square plus 2a square, correct? And this will be cos phi. So we are going to get here 2a square plus 2a square cos phi, and on the other side they are saying resultant is root 3 times of a. So this is root 3 times. So here if we are going to write, this is going to become basically 3a square, which is going to become basically a square equals to 2a square cos phi. Yes or no? So this will be basically 1 by 2, phi will be 60 degrees, correct? So what is the next one we are having now? Next one is equation of a wave is given as y equals to 10 to the power minus 2 sine this, where x and y is this speed of the wave. बच्चों speed of the wave निकालने के लिए ओमेगा बाई के, ओमेगा है सर हमारे पास 160 बाई 0.5, ये हो गया सर 5 3s are 15, we are having 5 2s are 320 मीटर पर सेकेंड. बट सर ये पूछ रहा है हमसे किलोमीटर पर आवर में. किलोमीटर पर आवर में कन्वर्ट कर लेंगे बच्चों इसको, इस 320 इंटू 18/5, ये हो जाएगा हमारे पास 320 इंटू 18 होता है 5760 डिवाइडेड बाई 5 होता है अप्रॉक्सीमेटली 1152 किलोमीटर पर आवर. So 1152 would be your answer. What is the next question now? Last one. A closed organ pipe 150 centimeter long gives 7 beats per second with an open organ pipe of length 350 centimeter. Sir, frequency निकालनी है. What is the frequency of the closed pipe, sir? V by 4L, sir. V divided by 4L. It is 150 centimeter, which is going to become here 1.5 into 4, which is basically V by 6. What is F2 for us? V by 350 centimeter 2L, because open pipe frequency is बच्चों V by 2L, so it is going to become 350 centimeter, which is going to become, अच्छा ये this is in centimeter बच्चों, right? So we need to convert into meter, right? So it would be 3.5, it would be 7. So now frequency difference is how much? They are saying frequency difference is 7. So V by 6 minus V by 7, we are getting 7. This is going to become 7V minus 6V. This is V, and this is going to become 642 multiplied by 7, and 42 multiplied by 7 कितना हो जाएगा बच्चे हमारे पास 4, ये हो जाएगा 428 to 294 meter per second would be our answer. So we have done the whole thing, and I hope you have written a very good exam. Thank you so much guys. Bye bye.